Okay, so we know how to solve a system by graphing. This is the example that we did. Here's that first line, it goes down. Here's the second line in orange, it goes up. And we saw that it crossed at 1, -3. But there's another way of being able to do it, and this is by a method called substitution. And so if I have y equals -4x plus 1, and I have my other equation, y equals 3x minus 6, I can see that I have a y here and a y here. And if before when we did substitution, I might say something, I might tell you we have 2x plus 1 equals 3. Does x equal 4? And we'd substitute 4 in and then we'd solve. Well, what we're going to do here is I see that y and y, well, y and y are the same thing, right? So what I can do in this case is looking at my equations, I can substitute in for y. So if I have y equals -4x plus 1, I can then substitute that in for this y right here. So what I end up with is -4x plus 1. This, all I'm doing is instead of writing y, I'm writing -4x plus 1 because -4x plus 1 is the same thing as y. And I can set that equal to 3x minus 6. Okay? This is the substitution step. This is substitution. Can I get show of thumbs up, clear skies, partly cloudy, snowstorm? You guys see what I did here? Okay, I'll just go over it one more time just because I want to be as clear as possible. So all I did is this y and this is y. Y and y are the exact same thing because they're both y. But if this y is -4x plus 1 and this y is 3x minus 6, I can find where they cross when their y's are the same. So I can take this and set it equal to this. Why? Because y equals y. Y equals y. Y is the same thing as y. So this version of y, -4x plus 1, this is equivalent to y. It's like y is Victor and -4x plus 1 is my substitute teacher, right? If you came in here and you saw somebody else here, you'd be like, oh, that must be the person subbing for Victor today. And you wouldn't think anything of it except possibly try to pull a prank or make paper airplanes or whatever it is. This y is Alana. And, Alana's an English teacher as well. And then here she is with her substitute teacher. She has a substitute doing her thing. Boom. 2 substitutes. We just substituted in for y. So now that I have -4x plus 1 equals 3x minus 6, I can just solve this the way I would solve any other equation for one variable. So I'd subtract 3x, I'd end up with -7x plus 1 equals a -6. I would subtract 1, so I have -7x equals -7, and then I'd isolate my variable by dividing by a -7. Isolate my variable. X equals -7 divided by -7 is 1. So I have half of my point here. I know that the solution to these two equations, the point where they cross, is going to be x equals 1. Well, we know that from graphing, but if we didn't graph, we now know that it's true by doing this. But again, to find a solution, I need the full point. I know my x is 1, but I don't know what my y is. So to find my y, what I'm going to do is I'm going to take my x, and I'm going to plug it into either equation. Either equation will give me the answer. So let's say I do the blue equation. So I have y equals -4x plus 1. I'm going to substitute one more time. This time I'm going to plug 1 in for my x. So I have y equals -4 times 1 plus 1. So y equals, -4 times 1 is -4 plus 1. And then -4 plus 1 is going to be -3. -3. And so from all this, I see that my point where it crosses is 1, -3. And sure enough, 1, -3, that's exactly what we proved when we graphed it. So all that we're able to do is we're able to use two equations with two variables to solve where they cross, just like that. Thumbs up, clear as day. Thumbs sideways. Victor, I need to see this one more time. Thumbs down. I'm feeling good, or I need some help. Okay, cool. We're feeling pretty good about it, but what I want to do is I want to do one more example. I want you guys to get one more example in your notes. This time, both of these were in slope-intercept form. Let's see what happens if we're doing it in standard form. Okay, let's try doing it in standard form, because it gets a little bit more complicated if we do it in standard form. So say instead, I'll keep using blue and orange. I think those colors work well on the overhead here. Let's say I had one equation that was 6x plus 2y equals 4. And I had a second equation that was x minus 2y equals a negative 18. Okay? And this time I asked you to solve for substitution. Well, this one's different than the other ones, right? The other ones we had y equals, and we could just see what the y was, take that, put it in for the other y, and we were ready to go. This one doesn't have that. In this one, I have both my variables on one side of the equation, and I don't know exactly what to do. So our first step, step 1, is to isolate one of the equations for one variable. And you might be thinking, Victor, what the heck does that mean? What does it mean to isolate one of the equations for one variable? Well, we have two equations. We have the blue one. And I could treat it like any other literal equation and solve it in terms of x, or I could solve it in terms of y. I also have the orange one. And I could treat this like any literal equation. And I could solve it in terms of x, or I could solve it in terms of y. So we have 4 different options. There's a lot of options. We could do the blue x, we could do the blue y, or we could do the orange x, or we could do the orange y. We can solve one equation, blue or orange, for one of the variables, x or y. Now, mathematicians are inherently a lazy bunch. We try to do things the easiest way possible. So looking over our equations, which one looks easier to isolate a variable in? Give me one finger if you think it's blue, 2 fingers if you think it's orange. Which one looks easier? Which one do you guys think is easier? I definitely think orange is easier. Orange looks a lot easier to manipulate. With blue, if I were to isolate the x, I'd have to subtract 2y and then divide by 6. Dividing by 6 is going to give me a strange fraction. I could do y and divide by 2, but dividing by 2 doesn't give me that much more difficult of a fraction. But when I look at x, or when I look at orange, I'll kind of give you the answer there. What looks super easy here? The x doesn't have a coefficient at all. Right? The x doesn't have a coefficient at all. So I'm going to do that. I have x minus 2y equals negative 18. If I add 2y, I have x equals 2y plus 18. I'm done. I have isolated it for one variable. I didn't have to multiply or divide. All I had to do was add. So this was the easiest. This one was the easy mode. Okay? X, the other ones, the blue equation or doing this one for y, would have gotten you there. Okay? There were 4 different ways to attack this problem. Any way would have gotten you there, but this was the easiest way. All right. So now that I have this, I've rewritten the orange equation in terms of x. You know, if you were wondering why we were doing literal equations so much, this is why. We need to know how to do this. So now what I'm going to do is, if this is x, I'm going to substitute this into my other equation. I'm going to substitute this into the blue equation. So my blue equation was 6x plus 2y equals 4. But now, instead of x here, I'm going to write what x equals. So that means I'm going to have 6. And what does x equal? X equals a lot. 2y plus 18. plus 2y equals 4. Thumbs up, you see what I'm doing here? Thumbs down. Want me to slow down a little bit?
Slow down.
Yeah, it is negative 18. My fault. Thank you for pointing that out. This is a negative 18.
Silly goose.
David, what can I go over again?
Actually, never mind. You got it. I got it.
You feel good?
Yeah.
Okay.
I just slowly.
Slower. No problem, man. So now, this is supposed to be a negative 18. I miswrote it. So now I'm just going to solve for y. That's all I have to do. So I have this 6. I'm going to distribute it. 6 times 2 is 12y. 6 times negative 18, well, gosh, that's a big number, isn't it? Can someone do that for me real fast on their calculator? 108. Can I get confirmation? Thank you. And then I'm going to add another 2y, and that's going to equal 4. I'm going to combine my like terms. I have a 12y and a 2y, so really I have 14y minus 108 equals 4. I want to get my y term by itself, so I'm going to add 108. I'm going to add 108. I'm going to end up with 14y equals 112. And finally, I'm going to divide by 14. Divide by 14. And I think this is 8. Can someone double check that for me? It is 8. Thank you. Y equals 8. Okay. Cool. Right? Y equals 8. So now we're halfway there. Now we're halfway there. We know that the y is going to be 8. So what do I have to do? What do I have to do? Because this is our second step. Our second step 2 was substitute. What do I have to do to get the final answer here? Step 3. What do you guys think I have to do? I have this y equals 8. What? Plug it in. Yeah. Plug in to... Does it matter the blue or orange?
No.
Not in this case. Plug into either equation. The easiest one. Always look for the easiest one. In this case, I think the orange one is easy. Right? Because this one's just x minus 2y equals negative 18. So x minus 2, and then in this case y equals 8, equals negative 18. Negative 2 times 8 is a negative 16. If I add 16, I have x equals a negative 2. So there's that. And finally, I can put it all together. My answer is negative 2, 8. And so now I know without having to actually graph it, where these two lines, I know where they are going to cross. They're going to cross at the point negative 2, 8. Yeah, Tessa.
Well, if you're just going to keep the problem how it is, what's the point of doing the first step?
This step here,
Yeah.
we need to figure out what x is, or y. Because when I took this and I plugged it in here, right?
Okay.
So if we're given it in standard form, we don't have x equals something or y equals something. In our first example, we were given this, right? In our first example, it was y equals, so it was already ready to go. But for this one, it wasn't. We kind of had to do a little bit of prep. It's kind of like, when you're cooking, sometimes you have to chop the garlic yourself, you have to cut up the vegetables, you have to wash everything down, or sometimes it's ready to go for you. You just put it in the microwave and you're ready to go. This one we had to do a little bit of prep cooking. The other one is microwavable. Yeah?
How'd you get for y on step 3, 8? Oh wait, is it from y equals 8?
Yeah, we know y equals 8, so I
Oh.
just plugged the 8 in for the y. It's just another step of substitution. Okay? Just another step of substitution. Cool. Any other questions on these? Yeah?
How would you get your work back?
You would just graph both the equations. So in this case, find your intercepts, see where they cross. See if they should cross at negative 2, 8.
With the order pair, would you put negative 2 and 8 onto equation corner?
You would, if you took this and you plugged it into the blue equation, it should be true. And if you took this and plugged it into the orange equation, it should be true. Absolutely. So that's another way to check your work.
Okay.
Yep, because it should be true for both.
One-way bridge.
That's the way it's a solution. Beautiful. Easy. Breezy. Lemon squeezy. Okay, guys, I'm going to power off the recording.